Welcome everybody to the our end of term TWed Lightning Talks for the spring 2020 term and the COVID-19 season. This is our first virtual Lightning Talks in the approximately 10 years that we've been doing TWeds. And thank you for being able to join. A couple logistics for this evening. First, Lightning Talks, we'd like them to be about 2 minutes long. You don't have to fill that time, but if you go long, I'm going to blow the horn on you. Or a different horn. I might blow the other horn. So I'd like to keep the length good, keep it short and sweet. The second rule that I really like people to comply with is please turn on your video, either through the whole thing or when you're talking. This is meant to be a social occasion, and we don't have the opportunity, unfortunately, this year for us all to pack into Winslow 1140. So please go off your video mute when you talk. I've got the schedule in front of me, so I will try to follow through on that sequence. And let's, after each person finishes, please thank them with the kind of appreciation that you'd like your talk to be received with. So without further ado, Brenda, why don't you kick us off?
Well, okay, but actually I don't have my camera connected, so I'm going to start off with being a bad student already. So sorry about that.
Just go for it.
Okay. So my TWed talk is titled Networks, an Allegorical Tale. And let me go ahead and start. So sometimes on the way to your PhD, you're presented with opportunities to experience things that you aren't sure will contribute to your end goal. And tonight I'm here to share an unusual experience that Shweta Narker, myself, and others had this semester. RPI professor Karen Rogers, she's the principal investigator for the Rensselaer Astrobiology Research and Education Center, known as RARE, conducted a never done before type of experiment. And part of that experiment required returning scientific samples to RPI from the Gulf of Mississippi. The samples were actually taken from 50 meters below the mid-Cayman Rise, and they needed to be brought back to RPI at both temperature and pressure. This was Karen's experiment, and it's a pretty impressive thing that she did. Again, never before done. So anyway, as will happen in never done before experiments, plan A, plan B, and plan C to return them became non-options. And so essentially a new edge case appeared. In the scramble to develop a plan D, Shweta and I were called upon because our location made us an edge in the network and because the people involved made us a node in the network. Our PhD adventure involved grabbing Ahmed Elish to take us downstate to Long Island, where we picked up a 19-foot refrigerated van. And for the next few days, Shweta and I drove to Mississippi to provide a way for those scientific samples to be transported back at temperature to their new home at RPI. We're pleased to say that through the efforts of everyone involved, those samples actually made it home safely. And Shweta and I like to say that we saved science. So we had an amazing adventure and a really great time in those few days. So basically, what does this have to do with TWC networks and research? Ahmed, Shweta, and I use network theory and graphs in our own work, and a lot of the experiments and things that we're running, data that we're working with. And this particular PhD adventure that we had was a real life example of networks evolving by forces acted upon it, and also worked in demonstrating how nodes can supply edges previously unexplored, and how edge cases, no matter how carefully they're planned for, can break a program or not. So that's basic.
That's pretty awesome, Brenda. Now everybody else has to live up to that.
It was fun. It was great.
Yeah, that's hard.
All right. So next up is Atish.
John,
Yes.
I have a question for everyone. Does everybody realize, you don't need to answer, just answer in the chat, does everybody realize what samples under temperature and pressure actually are? So please continue.
So yes, please feel free to we have the advantage with this webinar that we can have side questions going on and side conversations. So so take advantage of that, and that's a good kickoff question, Kathy. All right, so next is Atish.
Okay, I'm going to quickly start my stop clock. So, hey everyone, I'm going to talk about what we did over the, over the spring semester with CodeGraph. So, the question that we were trying to address is basically, how do you recommend to Python developers what they need, and how do we make their life easy? So, as you know, we have a lot of Python related information stored in the form of doc strings, Stack Overflow posts, etc. So these are also stored in knowledge graphs. To make recommendations, we want the text and the knowledge graph information to be represented effectively in a lower dimension. So how do we ensure that the embedding happens properly? We explored various embedding schemes throughout the semester. For knowledge graphs, we explored a lot of walks, but the problem with graph walks are they're not really scalable. And in addition to that, knowledge graphs are directional, and to capture that information is a challenge. In addition to that, we are also trying to leverage textual information. So we started off with latent semantic analysis. We did, represent the graphs, the textual information successfully in a lower dimension, but only to a certain extent. Even with MapReduce and Hadoop, for the large number of files that we are dealing with, it was a challenge. Doc2Vec is something that we're looking at now. We've done a pretty good job at it, and we are also looking to, come up with an alternate just in case. Hopefully, I've successfully managed to translate my higher dimensional time-related knowledge into a lower dimensional time scale. Thank you.
All right, Atish, thank you very much. Very interesting. All right, next in the list is Shruti.
Yeah. Hi everyone. I'm Shruti. I am a first year PhD student, being advised by Professor McGuinness. And I have been working with and um, and I have been working with the HEALS project. Last semester, if you recall, uh, um, um, I spoke about a review of 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 the explainability literature we undertook. Uh, uh, um, 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 during that review, we found different explanation types in the literature. and this semester we submitted and this semester using the review we made we made 3 contributions, I might say. Firstly, firstly, we submitted firstly we submitted firstly we submitted firstly we submit firstly we submitted firstly we submitted book chapters on the foundations and on the foundations and on the foundations and sorry on the foundations and on the foundations and directions for explainable and the foundations and directions for explainable knowledge enabled system. And post that we conducted a requirement gathering exercise with and post that we conducted a requirement gathering exercise with clinicians from Duke, um, trying to understand and also demonstrating the use of explanations within the setting of guideline based medicine. And currently we are working on and currently we're working on an ontology of explanations uh, uh, um, um, so that system designers can benefit from this so that system designers system designers can benefit from this resource to be able to include the explanations as a core component of the AI systems they're building. While accounting for both the system and the user attributes. Yeah, and that's about it for me. And next semester there will be more to share. Thank you.
All right, thank you, Shruti. All right, next is Katie.
All right, hello, can everyone hear me okay?
We can hear you, Katie.
Okay, yeah, sorry I was a little late. So yeah, I'm Katie Chastain. I'm working with Dr. Peter Fox right now. I guess watch this space, pointing vaguely to my email. Hopefully I will be doing my candidacy next month about I'm going to do it. I'm going to write a gender ontology. That's the plan for my thesis. I've been doing lots of research into what sort of data we're collecting, and also, my experience with public health data has sort of given me an idea of what sort of information we're actually looking for when we're asking like what a patient's sex is. And we have a bunch of sort of different attributes of a human that we all associate with deciding sex, but no one thing, there is no, universal solution, no combination that will magically yield, 2 of this, 3 of another one means you are definitely a male or definitely, a female. And so basically I want to define and separate all of these ideas from each other and store the data that way so that no one is making a judgment as to patient sex in the data itself. That can be decided by the data users, whatever is appropriate for their application. So yeah, I'll be around this summer, and by around I mean in Troy, not seeing anybody, but yeah. So I'll be doing my proposal probably via WebEx too. So that's what I'm looking forward to right now.
All right. Thank you, Katie. All right. And other people were clapping too. It wasn't just me. I could tell. All right, Sabir, rock and roll.
Muted. We were clapping. All right. So, hi, I'm Sabir. I work with Deborah McGinnis. I'm just going to take this opportunity to talk about some research I've been interested in that's not my funded research. So we know there's like a lot of ontologies out there in different domains, and usually they're kind of application specific. And we know a lot of work's been done in the biomedical domain in particular. And usually they're used for research purposes, but I've been wondering, like, to what extent can these ontologies be used for teaching, right? So, and in order to do that, would you need an education ontology in itself? And so if you had an education ontology, you'd think you would be able to use it for lesson planning, creating syllabus, creating course material, even lectures. So how would you leverage existing ontologies as well as the education ontology to do that? Can you automate the teaching process in some way? How much human input would you need? And like I mentioned, most ontologies have been kind of in the biomedical space. There are ontologies outside of this space, but for teaching a broad curriculum, even like at the high school level, you need more ontologies prevalent in subjects like math, the different sciences aside from biology. So chemistry ontologies exist, but they're not readily usable for teaching. How about a physics ontology? I've been thinking about that for a while. Even like English language ontology. And then if you have these ontologies that you can use to teach courses, can you also then use them for research? And so instead of going from research to try to teach, can you have ontologies designed for teaching that you can do research with? So for example, I've been working on a grammar ontology where I'm kind of using it to do new forms of NLP. And you can say the same for math ontologies or computer science ontology. So yeah, so I'm just interested in to what extent can we use AI for teaching purposes?
All right, very cool. Thank you, Sabir. And other people are clapping as well. All right, next is Feifei.
Hi, this is Feifei. I will be talking about 2 things I worked in the past year because I missed last semester's lightning talk due to I was doing my residency at New York City. So basically I work on 2 projects. One is the data augmentation project for hypermin detections. So a little bit background, what hypermin is the basically the is-a relationship in knowledge graph or taxonomies or ontologies. Basically, we are discovering the parent-child relationship, which means that the child is instance belongs to the parent. And one issue with the hypermin detection is basically for all the benchmark data set in the training set and testing set are basically there are very little overlap. That means there are a lot of odd vocabulary words. So the approach we're using is to introduce open domain or domain specific knowledge that we can take care of all the vocabulary words by data augmentation. that means we're augmenting on top of all the existing models. For example, we have one state-of-the-art model right now. It's a strict partial order network. So we can build on top of that and then do a better job comparing to the model as it is. Another project I was working on is the table question answering. Basically, what I was doing is to, so by given any natural language questions, we're target to find a specific table within a bunch of documents, and we're locate the correct cell value that can be used to answer the question. Currently, we're only focusing on the lookup questions. That means we're not ignoring them, but we are more focused on the questions that can find it answered directly from the table, without any calculations, any maximization, or any sort of additional work that we have to do on top of the table it is. So currently we're using a neurosymbolic approach, using the knowledge graphs and the Wikipedia and all the existing knowledge bases. But as the meantime, we're also exploring deep learning and neural network approaches as well. Thanks, that's it. That's pretty much everything I have.
All right, Feifei, thank you very much. That's very cool. All right, Ahmed, you're up. Rock and roll.
Thanks, John. Hello, everyone. I'm Ahmed Elish, working with Professor Fox. And the work I'd like to talk to you about today is related to work I'm doing for my thesis. Now, I know many of us are aware of and work with data in some form or shape of a network or graph, whether they are repositories of knowledge or observational data sets in network form. And having those data sets in that form allows us to apply concepts from graph theory as well as some algorithms along with linear algebra to learn things about the systems or the domains being represented by the data. Now, there is a class of methods that can be termed under graph entropy that that do have various approaches of computing entropy or the information content of a graph or a subgraph, and they come from various very specialized domains like molecular chemistry and statistical physics. So these methods are many, and they use different approaches, but the basic idea is to find a probability distribution that describes the nodes within a network, and then to apply an entropy function like Shannon's entropy function to that probability distribution to obtain some kind of measure for a particular node or a particular group of nodes, and that can give you an indication of their complexity. And the types of applications I'm thinking for are things like machine learning, for example, embedding or evaluating the embedding, a particular embedding scheme by using these sort of graph entropy measures. That's it for me. Thank you.
All right. Thank you, Ahmed. Were you on mute the whole time? Your video just came on just now, but did you have your video on before? Because it wasn't showing up. I don't know.
A little earlier, I just did.
All right. So next is Anirudh.
Okay. Hi, everyone. I don't want to show my quarantine self, but hello, quarantine beard going. Anyways, so I'm going to be talking about like a project that I've been working on for the last year and a half or so. It's something I've spoken to most people at some point in time that I would do it. So I finally did it. So I get to talk about it, and we're writing a paper. So I'm talking about predicting unknown mineral occurrences using affinity analysis. As many of you are aware, we have a project working with a bunch of mineralogists. It's called 4D. Now it's called 4D. It used to be DTDI. 4D stands for Deep Time Data Infrastructure. No, Deep Time Data Driven Discovery, 4Ds. All right, so part of that is working with mineral data, trying to find scientific insights that lead us to proving the coevolution of geosphere and biosphere. So while working with these mineralogists, we've been answering a bunch of scientific questions, but the core question of mineralogy, or one of the core questions of mineralogy, is, so where should I dig? where should I go to find what mineral? So that was posed to us, as part of a discussion, and it got me thinking on how to answer that. And we found a way, and it actually works. So we're writing about it. Affinity analysis or market basket analysis is the method that most recommender systems work off of. Whether it's Walmart or Amazon or so on. What you buy from Walmart, what combinations of things you buy, you can use that to predict what else the person is going to buy. Similarly, minerals occurring together on Earth, what combinations of minerals occur where on Earth can be used to predict where else are they going to occur on Earth that they have yet to be discovered. So that's kind of the method we have used. I have a poster at AGU. We're writing a paper, planning to submit it to Nature Geosciences. I'll keep you guys updated, but we have a preliminary set of results. It's preliminary set of predictions that people are now working on verifying, basically trying to go there and find things. We already have some ground truths that have been proven with a smaller version of this model. So that's very encouraging. And that's about it. Thank you.
All right. Thank you very much, everyone. Very cool. Very cool. All right. So we have Sam, and Sam, it looks like you are on now. I know you couldn't do it before.
Yep, I'm here.
All right, rock and roll.
All right. Hi, everyone. My name is Sam Catcher. I am a master's student in information technology with a concentration in data science analytics. I've been working under Professor Fox. And what I wanted to share about today was the work that I did for my master's thesis. I defended my thesis last Friday. So what I did was basically I looked at comparing different kinds of analysis and made a whole bunch of different pretty pictures while doing that, some of which were interactive because I compared using Tableau and R for visualization and analysis. Not exhaustively, but in the context of the data set that I was using, which was data from the Smithsonian Institute, which was pretty fun to work with. So what I did was compare Tableau style, more businessy interactive visualizations with network analysis done using iGraph in R. And basically the results that I came up with was that Tableau was a great tool for exploratory analysis, and R was a great tool for more intensive network and general data analysis, in that Tableau is a lot faster for prototyping than R. But the interface, the drag and drop interface for Tableau is a lot easier to use, but you have a lot less control for the visualizations you're making because you're relying heavily on templates. And for R, the ability to control a lot more aspects of your visualization, especially when you're working with networks, is really useful. I did not use any other visualization other than iGraph for this project. And that was kind of what I wanted to share.
All right. Thank you very much, Sam. Sorry for picking on you. We should talk offline about Viz Network. It really complements iGraph.
Yeah, I'd love that. Thanks.
Yeah. All right, Sola. Is Sola on?
Yep.
All right.
So sorry, my laptop's camera isn't cooperating, so no video.
Yeah.
Hi, so I'm Sola, working under Professor McGinnis. And so I don't know about everyone else, but during this whole quarantine and social distancing stuff, I've been cooking for myself much more than I used to during the semester. And to kind of get that homesick feeling away for not being able to go back to Japan for a very long time, I've been trying to cook some Japanese food for myself a lot. But one of the issues that I found myself running into there is that several of the ingredients that are kind of core to the flavors that I want, I'm not really able to buy in this area very easily. So we got to the kind of core project that I've been trying to work on for the past semesterish of substituting ingredients. So when we're trying to find ingredient substitutions, most of the time we want to be trying to find ingredients that either are serving some specific purpose, like maybe trying to avoid a certain allergy, or you're trying to make your meal have less carbohydrates or something, or like in my case, you're just missing some ingredients and you want to try to make the same recipe, have the same flavor profile with just swapping around some ingredients. And so I've been trying to use the food KG, which was developed a while ago by some other students, and trying to identify substitutions of ingredients from there. And so with the recent progress that I've been making, I've kind of been able to find some good results using a combination of word embeddings from word to vec models that were trained on the original corpus of recipe 1M that FoodKG was developed from, as well as kind of more general word embeddings from other sources. These two different word embeddings actually kind of provided some complementary uses for my case. And in addition to that, generally ingredients that would act as good substitutions for each other would kind of be used in similar recipes or used alongside other similar ingredients. And so I've been trying to use that sort of semantic information that's captured in the food KG. And finally, also trying to use some information about things like the classification of foods that's captured by food KG. For example, if I'm trying to look for a substitution for a potato, I probably don't want to be getting options for different varieties of potatoes, like Yukon potato. I want to find some other ingredient, like, say, cauliflower, for making mashed cauliflower in place of mashed potatoes. Yeah, in terms of actual results, it's been questionable, but working on that. Hopefully it'll be able to come together to something soonish. Yeah, that about sums up what I've been working on.
Questionable into how it tasted. Thank you very much, Sola. All right, so next is Cara.
Can you hear me?
There she is. We can hear you.
Right. I'm really craving Japanese food right now. Hi, everybody. I'm Kara. I am a fifth-year student working with Jim Hendler, hopefully a last-year student. As you may have heard a few times before by now, my work has been on developing an artificial life simulation called Garden in order to conduct experiments about the interaction of genetics and social behaviors in simulation. Garden consists of an environment filled with various objects, as well as agents that have different needs, such as fullness. These needs are affected by time, so the agents can starve to death if they're dumb, which many of them are, as well as the agent's interactions with objects or other agents as it moves around and through the environment. Each agent is controlled by an individual neural network, which are created from their evolving diploid genetics. Diploid meaning that they have two copies of their genome as opposed to the one copy that you usually see in something like a genetic algorithm. So I first used the simulation to test this 2 versus 1 copies of the genome in both static and changing versions of the environment. And since then, I've been moving towards adding different social dynamics to the simulation. For example, I've been looking at how adding genetic factors such as inbreeding or perhaps genetic disorders can influence behaviors such as mating choice, and also how mating choice behavior influences things like the genetic diversity of the population. I just passed my thesis proposal, so now I'm working on refining the experiments I propose to meet the approval of my committee.
Very cool. And congratulations on getting through your proposal. That's always a huge step.
I was very relieved.
All right, next is Sweta.
Hi, I'm Shweta Nalkar and Fox. We're talking about one of my other projects that I'm doing up in the industrial department. So it's basically into the field. What we are trying to bring into the through empirical research is something called as improvisation, which actually is very hard to do. So it was an experiment which was set up in a. Are you asking?
It's a little hard to hear you, Shweta.
Oh.
Maybe just lean closer or something.
Is this better?
Yes, it is. Thanks.
So it's a project in cognitive science, and we're trying to study improvisation and how the process of perception, cognition, and action works together as one entire. For this particular project, we have data collected from a team of emergency response personnel who were up against a simulation and how they were interacting throughout this process. And using that data, now we are trying to define or empirically measure how improvisation works. We are sticking with the definition that it's a convergence of planning and execution, where the emergency personnel initially spend time interacting and planning what they're supposed to do. They use their existing knowledge base, but actually analyze the situation or the emergency they're facing, and they go about taking decisions. And the improvisation that comes into the picture at that last moment has so many different features like latency, activity, intensity, and that's where we have diverted this semester to study and to be able to answer these.
All right. Thank you. Jason, do we have you on the line?
Yes, I'm on.
All right, rock and roll.
Yeah. So hello everyone. So I'm Jason. I hope everyone is staying well and healthy during this special period of time. So I'm a PhD student advised by Professor McGinnis. So for this semester, I'm working on the MCS project, Machine Common Sense project. Background for this project is that people want to explore common sense knowledge for supporting common sense question answering system. So regarding the common sense questions, like as one example from the catnap paper. So let's say, where do adults use the glue sticks? So in order to answer such questions, we need some common sense knowledge, like we human is capable of work. The work should be at the location of office, and then the glue stick is actually will be normally used in the office. So we can actually by knowing this kind of knowledge, we are able to select the correct answer. We from three options, maybe A is classroom, B is office, and C is some desk drawer. So it's actually a very challenging problem, because the acquisition of common sense knowledge from natural language corpus is very hard, because it's not like some ordinary or general information extraction system that is working around is working mainly for some name entities for extracting their relationship or the properties of the name entities. So what we do in the project is we use ETL process, extract, transform, and load process to try to establish a common sense knowledge graph by transform some knowledge from some structure sources. And we are also leverage the pre-trained language model, which is very popular in recent 2 or 3 years, to try to learn a relation prediction model given two concepts regarding some common sense entity, like so if we input birds and fly into the machine learning model, the model can pre-train language model is able to predict the relation between two concepts should be something like capable of. So, what we found, something that is very counterintuitive is that the model based on pre-trained language model is not better than some traditional INN recurrent neural network based model, which use some pre-trained word embedding like the graph embedding. So we may need to investigate these issues in the future. But our plan next step is to try to investigate some failed cases of those neural network models for question answering for common sense, to analyze the failed case, and then to see what are the cases that a common sense knowledge base can contribute to better performance. So I think that's it for me.
All right. Thank you, Jason.
No problem.
Glad you could join us tonight. So I think that's it for the students. So thank you all very much. This has been our first virtual TWed Lightning Talks, and it's excellent. And there's going to be a recording of it. Deb, I see that you're on. Would you like to close things out with some pearls of wisdom for these wonderful people?
Well, I don't know how many pearls of wisdom, but this kind of short presentation of your work is really spectacular practice for you. So we greatly appreciate you doing it, and really exciting work. Keep doing the good work and making us all proud.
So with that, thank you, Deb. With that, thanks everybody. Stay safe. And this recording is going to be posted to the TWed YouTube channel and probably the IDEA webpage, which has a nice place for putting talks. So thank you very much and have a great evening.
Thank you, everybody.